Hello everyone, I'm Mizuki Odaira from Toyohashi University of Technology. Today I would like to talk about fabrication of multimodal image sensor capable of simultaneous measurement of pressure and pH. In recent years, cardiotoxicity evaluation methods for medicine using cardiomyocytes are being actively developed. And this makes it possible to expect efficacy and toxicity of medicine for heart in the early stages of medicine discovery. And here, beating of cardiomyocytes is caused by exchange of ions inside and outside the cell. So ionic activity of cardiomyocytes is an important parameter in evolution of cardiac function. And mechanical activity of cardiomyocytes is also important parameter. So simultaneous measurement of ionic activity and mechanical activity would contribute to medicine discovery and understanding of cardiac function. Our research group have been succeeded in visualizing changes of hydrogen ions and pressure using CMOS sensor array. This is a result of pH imaging, and this is a result of pressure imaging. In this pressure image sensor, pressure is measured by attaching a piezoelectric film on the pH image sensor. Here I explain each principle simply. First, pH imaging sensor. In the pH imaging sensor, hydrogen ion sensitive membrane is deposited on CMOS sensor array, and binding and dissociation of hydrogen ions changes the surface potential, and sensor output changes accordingly. And on the other hand, pressure image sensor, piezoelectric film is attached to the pH imaging sensor, and when piezoelectric film is deformed by applied pressure, the surface charge of sensitive membrane changes and potential changes, and sensor output changes accordingly. The output waveform due to piezoelectric effect is characteristic, so introduced here. First, piezoelectric film is pressed. The output decreases and return to the initial value as the pressure continues applied. And when the pressure is released, the output decreases and return to the initial value. Going back, both sensor measure pH and or pressure from changes in the surface potential. So the two sensors can share the sensing circuit. So in this study, we aim to fabricate a multi-image sensor capable of visualizing pressure and ions. simultaneously by patterning the piezoelectric film on the pH sensing image sensor. Here I explain how to fabricate the sensor. First, hydrolyze piezoelectric film and pH image sensor and attach a piezoelectric film to the pH image sensor by use pure water. And next, formed pressure sensing area by photolithography and IEEE, and then coat PVA as a sacrificial layer, and then conduct photolithography and PVA removing, and then deposit gold. This is a waterproof membrane of pressure sensing area. And finally, I lift off the PVA for forming pH sensing area. This is a picture of actual fabricated sensor. Pressure sensing area and pH sensing area of 20 micrometer square formed. So we succeeded in fabricating the target pattern. Next, we conducted pH imaging experiments using the fabricated sensor. To get a higher pH, drop disodium hydrogen phosphate to the sensor. This is a result of imaging. The output of pH sensing area changes direction of higher pH and pattern is visible. Therefore, from pH sensitivity measurement, a good sensitivity of 63.4 millivolts per pH was obtained in the pH sensing area, and pressure sensing area showed almost no response to pH at 3.0 millivolts per pH. So this shows that the waterproof membrane of pressure sensing area are functioning. Next, we conducted pressure imaging experiment. The pressure is applied with pipette tip. This is the result of imaging. When the pressure is applied, the pressure, the output of pressure sensing area changes and pattern is visible. The output of each sensing area shown in the graph. From this, only the pressure sensing area is responded and shows waveform characteristics of piezoelectric response. Next, we conducted simultaneous imaging of pressure and ions. This experiment using pipette tip containing disodium hydrogen phosphate solution, and first the solution in the pipette tip is mixed into the solution on the sensor. And as a result, the pH is higher. And next, press the sensor with the pipette tip. In this way, a simultaneous imaging of pressure and ions can be conducted. This is the result. First, the output of pH sensing area changes direction of higher pH, and then the output of pressure sensing area changes. Here show enlargement of the video, and the output of each sensing area shown in the graph. From this, pH sensing area responds only to the pH of solution, and pressure sensing area shows a waveform characteristic of piezoelectric effect. So from this, we succeeded in simultaneous imaging of pressure and ions. This is the summary. In this study, we aim to fabricate a multi-image sensor capable of visualizing pressure and ions, and we conducted fabrication of pressure and ion image sensor and imaging experiment of ions and pressure. As a result, we succeeded in fabricating a multi-image sensor with alternating ions and pressure sensing areas of 20 micron square each. And we have succeeded in simultaneous imaging of pressure and ions. Thank you for your attention.